In the friction simulation you're going to do for this flex day learning, you're going to be checking out the relationship between the friction and the normal force, the friction and the surface area, and the kinetic friction and the weight of the block. So in each one of these you have to make sure it's kinetic friction, not static friction. So for instance, the first one, the weight's going to stay constant, so you wouldn't change the mass down here. And the surface area will stay constant, so I won't change that. But what you're going to do is you're going to be varying the normal force. So you put it up here, and you can pause it if you want, and it tells you what the normal force is. So you'll record that normal force. And you'll also record the friction. And the friction is going to be equal to the x component of the weight. I should say the net force is going to be equal to the x component of the weight minus the friction. So if I want to find the friction, I'd need to take the x component of the weight minus the net force. So they give you the x component of the friction, and it's kind of hard to see here, but it's 3.163 newtons for me. And I would have to take the mass, which is 1, so I'm going to subtract the net force, which would be 1 times the acceleration for me, since the mass is 1. So 1 times 1.307. Then I need 6 data points, so I can do that by getting different angles here. And now recording the normal force, and the friction again is by taking the x component of the weight minus the net force, which would be the mass times the acceleration. Then the next part of the lab, I'm going to be keeping, make sure, by the way, you record what the constants are. In this case, the constant was 10 newtons for the weight, because it's 1 kilogram, and the surface area was 4 centimeters squared. For the next part of the lab, I'm going to be keeping the weight constant, and the normal force is going to be constant, but the surface area is going to change. So it's pretty easy to do this part, so I'll just choose whatever I want, and for the surface area, and record the information. So the weight for this, I have it at 1 kilogram, so that would be 10 newtons. The normal force for me is 8.775 newtons. And I will not change the angle, and I won't change the mass, so those two will remain constant. My surface area is 1. And to figure out the friction again, I'm going to have to take the x component of the weight minus the net force. For me, that would be the mass times the acceleration. So 4.364 minus the mass, which is 1 for me, times the acceleration, 2.609. And I'm going to have to get 5 more data points. For the third part of this, this is the hardest part, figuring out the relationship between the kinetic friction and the weight. I need to make sure that my surface area is constant, so that's not hard, whatever you want it to be, so let's say 1. But my normal force cannot change, so notice my normal force right now is 8.775, and that can't change. So the only way that I can change my weight without changing the normal force is by changing the angle. So for instance here, the weight would be 10 newtons because the mass is 1 kilogram. The friction force would be the x component of the weight minus the net force, which would be for me 4.364 minus 1 times 2.609. To get the next one, I'm going to have to change the angle after I change the weight. So let's say it's 11 newtons. So that would be 1.1 kilograms. And you can see that automatically changed the normal force. I need my normal force to stay at 8.775. So I'm going to lower this down. Excuse me, up. 8.775, and I can fine tune the angle here. Let's see. There we go. So I had to put in an angle of 35.51, and so now I can go ahead and play it and figure out what my friction force is. Again, it's going to be Wx minus the net force, which in this case is going to be 1.1 times the acceleration. So 6.262 minus 1.1 times the acceleration, 4.497. And so now I need to get some more data points for all of this. Okay. Then in part 2, what I want to do is I want to figure out the angle, the maximum angle that I can have so that the object doesn't move on me. So you can see right now that if I were to pick this up and put it here and start sliding on me, so that angle doesn't work, I'm going to have to find the angle that doesn't slide on me anymore. And you can see it's here it's not sliding, here it's sliding. So I need to find that angle where it just breaks free. And again, when I get close to it, I can dial it in by just changing the angle slightly here. And I also want to go ahead and record then my normal force and what that static friction force would be. Well, if it's not moving, the static friction force is just going to be equal to the x component of the weight. In part 3, what you're doing is you're going to be finding the angle such that it goes at constant speed. So notice what I let go here, it's accelerating. That's not working. I need to get it so the acceleration is 0, but it has to be moving though. So you'll notice that there it's moving. I need to lower this down evidently to my acceleration goes to 0, and again I can kind of tune it, and you can pause it and play around with the angle. But you need to record that angle, you need to record what the normal force is, and you need to figure out what the friction force is, again, which would be equal to the x component of the weight if it's going at constant speed. There's no acceleration. And that's it. So record that data. You'll want to graph in part 1, those 3 graphs, so you can figure out what the relationship is and linearize it if you need to. All right, good luck.